Okay, so we're solving rational inequalities. I really think you guys are going to be fine, even without a whole lot of instructions. What do you think we do first?
Restrictions.
We are. We're going to look for restrictions, and we're going to look for zeros. Do you guys remember when we solved polynomial inequalities? Okay, so when we solved polynomial inequalities, that's what we did. We did a sign chart. We listed all the zeros, and then we tried to see what was going on in between. Well, now we're dealing with rational functions. So not only are we looking at the zeros, we're also looking at those restricted values, which on the graph would give us what? Asymptotes or holes, that's right. So this one's already set for us. We don't really have to do much. Let me get it. Here we go. So we can go straight for our sign chart. And so on our sign chart, we're always thinking negative infinity over here, positive infinity over here. This is going to have two of those critical values. What are they?
-1.
Okay, so -1. And -1 is actually a 0. And then we have 5, which is not a 0, it's an undefined. In this case, it would be an asymptote of the graph. So that's an undefined value. All right, now our book uses a U for undefined. I don't know that any of you use your book as a resource. Our answer keys all have the star for the undefined values. All right, and so now we just have to test. Let's pick something over here like -2. A negative divided by a negative is a positive. Good. Let's pick something in this interval like 0. So we get a positive divided by a negative is a negative. Good. Let's pick something in this interval. 6. A positive divided by a positive is a positive. Okay, so when we're solving these inequalities, once we get our sign chart, then we have to go back and take a look at this. This says where is it less than or equal to 0? So this is where less than or equal to is negative. Over which intervals is this negative? And so in this case, it's actually just one interval. Because it's less than or equal to 0, we can include that -1.
Oh.
But because 5 is undefined, we cannot include the 5.
So that's what it's meant.
So it goes from -1 to 5.
Wait, how is 5?
Okay. Huh?
How is 5?
Because 5 would put 0 in the denominator. So now let's tie this back into its graph. Let's say we were just looking at this part. Okay, what does this tell us about the graph? That's negative, that's below the x-axis.
Yeah.
From -1 to 5. Right? Okay.
It's probably like this and then like that.
Yeah. There'd be a vertical asymptote at 5. And another one at 0. No, at 1.
Yeah.
At 1. At 1. Okay? And then we have the 0 at -1. So what it would do is it would look like this, maybe? Oops, I missed it. And do you see how right here it's less than? And then here it's a positive?
Yep.
Okay. All right, so this is how we can do it algebraically without having to do the graph. Yes, sir? Sure. All right, questions about number 1? Okay, let's take a look at number 2. Number 2 has a little work. It's not quite there yet. Not much work, just a little. Yes, sir?
So like on that homework, are we going to have to get after 2?
No,
Just the limits?
just solve it algebraically using your sign chart. Okay, so this one, the numerator factors are what, guys?
X plus 1, X plus 3.
X plus 1, X plus 3. So if we tied this back into the graph, we wouldn't have any holes, but we would have a vertical asymptote, right? And we'd have 2 zeros? Okay. All right, so now let's go ahead and do our sign chart. What are our critical values that appear on our sign chart? Very good. -3, and that is a 0. -1, and that is a 0. And then +1, and that is a undefined value. Okay. All right. I want you to try to complete the sign chart. Test your values. See if you can determine where it's positive and where it's negative.
If there's more than a middle to use, you need one.
Mhm.
Ooh.
Okay, say we test a number over here, let's say -4. We get a negative times a negative times a negative is negative. Okay, we plug a number in here like -2. We get a negative times a positive divided by a negative. We got 2 negatives. 2 negatives make a positive. We plug in 0. Positive, positive, negative. 1 negative makes a negative. We plug in 5. Positive, positive, positive. Positive. Yes, sir?
Since it always goes negative, positive, negative, do we always have to do that? Just find one. I always just find one. Remember you guys
Let's keep doing some examples and make sure we do not assume that that isn't always. Okay? So we've just done 2. We currently do see a pattern. And if you remember, we saw patterns when we did higher degree polynomials, but something disrupted those patterns.
Multiple roots.
All right, so this one, where it's greater than or equal to 0, so we're looking at where it is positive. That is greater than or equal to 0. There's actually, there's no equal to here. It's just greater than 0. So we will not be using any brackets. As I said the word bracket, I tried to draw one. No brackets.
So included?
It's not included because there's no equal to.
Oh, that's right.
Yes, sir.
So if there's a hole, would you, and what'd you say was greater than or equal to? If there's a hole, you still need a parenthesis, right?
Yes. If there's a hole or, yeah, on any restricted values. Yes, sir.
Well, so if there's an equal to sign, then you can use brackets?
Yeah.
on the-
Like on this one, we could, because of the equal to, we could use a bracket on the actual 0, but we couldn't use a bracket on the undefined value because it's not really possible. Okay, let's take a look at this one. Let's see what you can do. Like this one's for you.
This is the sign thing.
Uh-huh. so in this first interval from negative infinity to negative 4, was that interval positive or negative? Positive. Okay, in the second interval from negative 4 to 1, is it positive or negative?
Negative.
Negative. In this interval from 1 to 4?
Negative.
Negative again.
Oh,
And then in this interval from 0 to infinity, from 4 to infinity, it is
Positive.
positive. Okay. Does anybody notice what may cause this?
Double root.
Double. All right. So that is a possibility. So we want to be careful about just always going with our pattern. All right. On this one, we want to know where it's less than 0. So we won't be using any brackets again. We'll go from negative 4 to 1. And then from 1 to 4, we're just excluding the 1.
So if there is a double root, can I do it?
I might make you special problems that need further investigation.
What if there's a triple root?
Then you can't.
Interesting.
Wait.
And it'd be negative, negative, negative.
All right, let's do it. What if we have the exact same problem, but this was x minus 1 cubed? All right, let's do it.
Is that even possible?
Good question.
Yes.
Why would that not be possible?
This is irrational. Is that irrational?
Well, now shouldn't it just act as a single root? Because now the denominator.
The denominator.
All right, so we still have the x plus 4, the x minus 4. And we have the x minus 1 cubed. All right, so if we chose negative 5, we get a negative, negative, and a negative. So it would be
Negative.
negative. If we chose 0, we get a positive, a negative, and a negative. So we have 2 negatives, so it is
Negative.
positive.
Wait, what? Oh, yeah, you're right.
Okay, cool. All right, if we chose 2, we get a positive, a negative, and a positive, so it would be negative. And 5, positive, positive, positive is a positive.
so it goes back to.
So we have odd powers versus even powers.
So 4 would go
At our
back to the
back.
plus, minus, minus, plus.
So it tells us what's going on. Okay.
Oh, wait, no.
All right. Now this is fun.
Oh,
Oh,
Absolute value.
Why not?
haven't seen this
It's
in a
the same
while.
thing as squared?
It does have the same effect as squaring and taking the square root, right?
You're so smart.
I know,
It just
right?
makes it positive.
Tell me a genius.
Genius. Well,
Okay, so I list my 0,
Wait, that's not.
I list my excluded value,
Shouldn't it be a positive 3 because it's absolute value though?
if I plugged in a positive 3, is it undefined? No, but if I plugged in a negative 3, I get 0.
The absolute value.
Yeah, the absolute value of 0 is 0, so I just can't have 0. Alright, so we test a value. Alright, say negative 4, we get a negative over a positive. It's always going to be over a positive, isn't it? So a negative over a positive is a negative. I plug in 0. I get a negative over a positive, which is negative. I plug in 5. I get a positive over a positive, which is positive.
What does the absolute value have to do with anything?
They just make sure.
Like the same thing as squared.
Oh, the denominator is
Not
always
squared.
positive.
Well, if we think about what the effect of what you were saying was somewhat correct, and the fact that when we think about the absolute value graph, it hits and bounces, right? And we think about when we have a factor that is squared, it hits and bounces, right? And so it's kind of having the same effect with our signs, doesn't it?
So, okay, so if I plugged in -4, it'd just be positive.
Yeah, the denominator is always going to be positive, no matter what I plug in, which is kind of nice because I can ignore it.
Which means that everything under x equals 2 is gonna be negative, and everything above is gonna be positive.
With the exception.
Always.
With the exception of
Okay.
our undefined value. Okay? All right, so what would the answer to this be? It would be from -infinity to -3, but I don't get to include the -3 because it's excluded. And then I would have to have union -3 to 2, but I can include the 2 because it is less than or equal to 0. And we're done. Okay? And that is it. All right, so let me swing by and give you the assignment.